Hey everybody, welcome to activity 6.3. So we're going to continue to take a look at motion graphs. If we were to quickly review activity 6.1, we took a look at a motion graph of a Newton's cradle. And we kept it really simple. We basically looked at, is it moving? Is it not moving? We added some time. And then in activity 6.2, we took it a step further. We talked about whether it's moving or not. And we had the time there, but we also added distance because we had a ruler. So in 6.3, we're going to use what we learned in 6.1 and 6.2, or at least you're going to use them to create a new graph. This new graph is going to be using the magnetic cannon. So our learning target today is we're going to use what we've learned to draw, or what we have learned to draw motion graphs of the magnetic cannon. So we're going to use that knowledge to take it a step further. One for the ball that activates the cannon, that's going to be ball A, and the other for the ball that shoots out. So the expectation for you is you can complete 2 graphs on the worksheet and answer the questions. Now the worksheet is really your book. So again, you can use this on the test. So again, do the best you can, taking good notes, getting everything down. So the test is open book. So if you have really good notes, the test should be pretty simple because you are going to have to do some graphing or interpreting of graphs. I'm not going to tell you which, but you are going to have to do one of the two things, either create a graph or interpret a graph on the test. So let's go ahead and get started. So here are the procedures. The drawing represents a magnetic cannon next to a ruler. So just like earlier in activity 6.2, we added a ruler. So here you can see ball A is at the 0 mark. And just let me quick grab a pen. So ball A is at the 0. Again, I don't want you to say, oh, it's a little bit before the 0. It's at 0. And then we can see where the other balls are. And what we're going to be doing is creating 2 graphs today, one for ball A and one for ball E. So when drawing the graphs, we have to assume you started measuring time from the moment that the entering ball A, is released, and it took this ball 1 second to reach. I want to circle 1 second to reach the magnet. So we're going to assume it took 1 second to reach the magnets. So that way every group has the same exact graph. Did it always take 1 second? Sometimes it took a little less, sometimes it took a little bit more, but sometimes in physics we want to have constants, things that don't change, and this is going to be one of them. So we're going to make 2 graphs today, one for the motion of ball A and one for the motion of ball E. And you're going to make both graphs on the same pair of axes. And so when you look at your book, so you should be in your book, you're going to see, and really the only thing you need to do for the drawing is you're going to have to click draw, and you're going to draw in your graphs here. Now you do have some making sense questions later on that you're going to have to do. But to begin with, we're going to focus on this. Now there's only one graph, so you're going to put both ball A and ball E on the same graph. So one of the things that you'll see right above the graph, it says, where is ball E located 1 second after it shoots out? And that's one of those things. There's no space for you to write anything. It just wants you to think about that. Where's ball E? So if it takes a second to get here, well, ball E is going to be here after 1 second. But a second later, how far is ball E? So in this table, or in this picture, we have it looking right here. Are you going to say, okay, well, that's 10, well, it's going to be at 11. But didn't it shoot out really fast? Is it really going to be there? Well, it is impossible to tell because you did not measure ball E's location after it shot out. We didn't take measurements on that. It moved so fast that it would have traveled a long distance. So we're not going to sit there and try and figure out exactly where it was a second later. So go ahead, you can open up your book, and we can make this first one together. So let's look at ball A. So ball A is released, and it took 1 second to reach the magnet. So ball A, again, it starts out at, if I look right here, you can see that it starts out at 0. So ball A is going to start out at 0, 0. We've got time, and we've got location. So it takes 1 second. Again, according to this, it takes 1 second to reach the magnets. So here you see ball A after 1 second. Where is it located at? It's located at the 2. So it took 1 second to go from here. So if I go to the 1 second, I've got to go up to the 2. So it took 1 second to make it all the way to the 2. So what did it do after that? We know ball E shot out, but what did ball A do? Can you remember? Did ball A go anywhere? Well, if you just pushed the 1 ball into the rest of them, it stayed put. It didn't go anywhere. So now what you want to do is you want to draw a straight line all the way across. So this straight line, and mine looks like it goes down a little bit, but it's fairly straight. This shows that the ball A is still 2 centimeters away from where it started, but a flat line here shows that it's not moving at all. I want to label this ball A. And if you just want to put it A, you can do that. So this is ball A. So now we have to create a second graph. So what I'd like you to do is I'd like you to pause the video, and I want you to create another graph, but this time for ball E. So go ahead, pause the video and see how you do. Did you finish it? Or are you just waiting to see what the answer is? So go ahead, pause the video. You're still playing the video, aren't you? So please go pause the video and give it a try. That way you'll have at least tried it. All right, so I'm hoping you actually tried it and you're not just waiting for the answer, because that's not how learning happens. Learning happens when we try things, when we practice things, not when we simply wait for the answer and copy it down. So we know a couple things. So if it took 1 second for ball A to reach this spot, what is ball E going to do for the first second? Well, it's not going to go anywhere. So if I look here, and it's right now it's at 7. So if I go up here to 7, and I'm going to try and estimate where 1 is. It's hard because it's way up there. So for 1 second, ball E isn't going to go anywhere. So then ball A hits and ball E shoots out really fast. So we don't know for sure where it went or how far it went. We didn't measure that. All I have to do is just draw a line, because it took off fairly fast. So we're going to have a steep slope. Yep, you're hearing that slope word that we've been studying in math. It's going to have a pretty steep slope. Now, one of the things I want to do is I want to draw an arrow here. Do I have to draw an arrow here? Well, this line could continue on forever if we keep going forever, but this is going to shoot out really fast. So how did you do? Here's the actual answer key. So we got pretty close. Oh, what didn't I do? You better make sure you do this, because if this is on the test and you don't have things labeled, you don't get credit for it, because I wouldn't know, is this ball E or is this ball A, unless you tell me. So I'm going to label this ball E. So I forgot to do it too, so hopefully this will be a good reminder for you. So here's the answer key right here. How did you do? Were you able to get it right? Are we able to think through this and be able to graph data? So that way, if you see something similar to this on a test, you can take care of it and do a good job at it. All right, so moving on, go ahead and answer the making sense questions. What kind of motion is depicted by a horizontal line in a motion graph? So we see this horizontal line. What type of motion is depicted by a horizontal line in a motion graph? Go ahead, pause the video if you need to. Otherwise, we're going to go on to number 2. All right, number 2. What kind of motion is depicted by a line in a motion graph with a small incline? So this right here is a fairly small incline. What kind of motion is depicted by a line with a small slope? So it could be that one, or if it could be like this, or it could be even less steep, although those are almost parallel. So what would those indicate about the motion? All right, and now question 3. What kind of motion is depicted by a line in a motion graph with a steep inclination. So you can see how steep this is. What kind of motion is depicted by that line? So go ahead, pause the video, and make sure you're finished with 1, 2, and 3. So how'd you do on those? Were you able to answer those? So let's go back and let's see how good you did. So what kind of motion is depicted by a horizontal line? Well, a horizontal line in a motion graph means that the object is staying at the same spot. So it's motionless. So if it goes across, if we were looking at math, what would the slope be? The slope would be 0. It's not increasing at all. So this would mean that it's staying put. It's not moving. So this is your location. It's 2 centimeters away and it stays there. Well, how about the next one? What about a small slope? Well, small slope or a small inclination in a motion graph means that it's moving slowly, that it's not going very fast. And if we remember when we did this experiment in this lab, I asked you not to take ball A and slam it into the back of the magnets. I told you just tap it a little bit and the magnet will pull it in. And then the last ones, this is going to be the opposite of 2. So if it's a really steep inclination or slope, it means it's going to be going really fast. And that's the thing that you saw with the magnetic cannon. Even though you tapped A just a little bit, ball E shot out really fast. So that would show a steep slope. Steep slope would show that you're moving really, really fast. So again, I hope you did well with these. And as always, if you have any questions, make sure you ask. Thanks.